Hello, everybody. Mr. Chan here for Algebra 1. We are going to start the next section, 2-3, standard form of a quadratic. Please get your note takers and turn to page 39. If there are any questions, let's go and get started here. So we have a little opener. Jay makes a playlist of 24 songs for a party. Since he prefers country and rock music, he builds the playlist from those two types of songs. So just to keep in mind what the two types of songs are, country as well as rock music. Great. And off to the right here, we have a playlist. There seems to be kind of a typo. I just want to make sure you guys know that. I just want to make sure that we're missing a couple of numbers here for country. It's kind of weird how that worked out. So let's go ahead and change this one right here at the back of the list, change that to country 13. And the next one, change that to country 22. Okay. All right. Let's get a little going there. Little musical notes. Let's take a look at what the first question is. Determine two different combinations of country and rock rock songs that Jay could use for his playlist. Well, if you take a look here, we have all kinds of possibilities here, but we want 24 songs. That's the key here. And to populate my list, you can make anything up you want to, as long as the two values you pick add up to 24. So I don't know, you can pick 2 country songs. Let's just pretend. And if you pick only 2, that means it leaves 22 for rock songs. Okay, that's just one possibility. Another possibility, maybe somebody wants to have more country. Let's pick 10 country songs. And if you take 24, subtract 10, that leaves us with 14 rock songs. So you can go on and on. Think of all the possibilities here, okay? All right. Next question. Plot those combinations on graph paper. Extend the line through the points. Fair enough. We do have 2 axes here. One is for, let's just call it the horizontal axis X, country songs, and the vertical axis we'll call the Y-axis will be the rock songs. We've already got 2 coordinate points already, 222. Kind of eyeball it, doesn't have to be perfect. We'll call that 222. 2, of course, is referring to the X value, the number of country songs, and 22 is referring to the number of rock songs. The other possible pair was 10 country and 14 rock. Let's plot that. Kind of eyeballing it as well. We are in the first quadrant where everything's positive. I'm only focusing on the first quadrant with the axes right now. If we extend the line, and because we're dealing with a real world problem, my graph should look something like this. But it stops. It doesn't go further. There's no such thing as a negative number of songs. And if you think about it, if we did have 0 country songs, that leaves everything else for rock songs, which is 24. Likewise, on the other part of the line segment, if we had 24 country songs, that means we'll have 0 rock songs. And there it is. It's a line segment with 2 endpoints. Next question. Can you use the line to find other meaningful points? Explain. Well, yes, you can. But you have to make sure that our values are only integers. These are whole numbers that are positive. Positive integers. Actually, that's technically whole numbers, aren't they? Positive whole numbers. All right. Let's go ahead and switch gears and move to the next page, page 40. Here we go. All right. Before we get started, it's probably a good idea to just do some vocabulary here. Let's use the space to the left here and identify a lot of things that we have worked with before in your previous math class. Draw a couple of axes. Horizontal is traditionally X and the vertical is traditionally Y. And they go on forever, left, right, up, and down. Anytime you have a line that crosses through those axes, we refer to the intersection as those intercepts of those particular axes. So the one right there is the first one that's on our graph is called our Y-intercept. And the other one is called your X-intercept. When you are trying to find the X or the Y-intercepts, the goal is to set the other variable to 0. Set the other variable to 0. That's key in finding the actual value for which the line or graph crosses through those axes, okay? All right. Now this particular section, 2-3, focuses on the standard form of a linear equation. Let's focus on what standard form means. Standard form is AX, capital AX, plus capital BY equals C. Question, is it easier to find the x-intercept of the graph of the equations in part B using the slope-intercept or standard form? Explain. So let's write down the slope-intercept form to compare. Y equals mx plus b. That is the slope-intercept form. And if you compare it to the standard form, question is, which one is easier? Whoops, a typo there. Should be a Y. Remember, the key is to set the Y value to 0. So I really kind of think it's the same amount of work when you set the other variable to 0. Okay, that's where it crosses the x-axis, the x-intercept. So if you were to set y equal to 0 right here, and then over here, I kind of feel it's the same amount of work to isolate x. Same amount of work. I don't know. It's kind of an interesting question. I don't really have a true answer to that. Let's just move on. I think the whole point of that was to make you think. All right. So this is no longer y equals mx plus b. This is all about ax plus by equals c. We're going to sketch the graph using a technique called the intercepts. We have 4x plus 5y equals 10. That is in standard form. Keep that in mind. We are going to graph it by using a technique called X and Y intercepts. To find the x-intercept, you want to set y equal to 0. Whoops. To find the y-intercept, you set x equal to 0 in the actual equation given to you. So let's do it. Here we go. 4x plus 5y equals 10. Put in the 0. That basically zeroes out, leaving with a 4x equals 10. Let's divide by 4 to both sides. that will now give me an actual number. In this case, it's 10 over 4 reduces to 5 halves. Or if you want to do it with decimals, 2.5. Great. We'll keep that in mind when we're trying to set up our axes. Over on the right-hand side, we have to find the y-intercept. Let's do the same thing. Set x equal to 0. That's the key. That zeroes out that term right there. You may have heard of the cover-up method, where you literally cover up either the ax or the by. It's the same thing. When you set something to 0, it basically makes it go away. It's like you're covering it up, so to speak. Divide by 5 to both sides, because the 4 times 0 goes away. That leaves me with y equals 2. All right. So what I need to do is plot those points on the x and the y axes, and they're both positive, which means our graph will be in the first quadrant. But you know what? We're just going to do this. We don't need to adjust too much. This is a totally different method of graphing, but it's kind of interesting. On the x-axis, go to 2.5 and put a dot there. 1, 2, 3. Put a dot at 2.5. Bam. On the y-axis, go to positive 2. Put a dot there. And all you have to do is just connect the dots, and that's your graph. We didn't have to worry about slope. We didn't have to worry about isolating y. This is just another method of graphing something that's linear, but it's in standard form. This is a cool technique. Any questions by example 2? All right, example 3 is kind of interesting. We are now faced with this situation where one of the variables is not there, either x or y has disappeared. When that happens, you either have a horizontal line or a vertical line. Take a look at 3a right here. 3a, and I'll write it off to the side. There's not a lot of room right there above the graph. 3y equals negative 18. All you have to do is isolate y. Divide by 3 to both sides. Y equals negative 6. Okay. How do we graph that? What does that mean? Y equals negative 6 means every point that you graph on this linear function means that every point is negative 6. So do me a favor, draw your x-axis here to give us a lot of room for quadrants 3 and 4 below it, okay? Every point has a y value of negative 6. Think about that. This is a negative 6, that's a negative 6, that's a negative 6. Wait a second, I think I went too far down there. Sorry about that. Let's count again. There you go. I was off by a little bit. Every point that's negative 6 for the y value gets plotted. So you see what's happening here? I'm basically filling in all the points, and when they do that, you form a horizontal line because y equals negative 6. In fact, I like to say, make a cross. Whenever you have an x equals or a y equals. Make a cross is to plot the point on the axis it equals to, like negative 6. And how do you make a cross with a vertical axis? You have to draw a horizontal line. Just a little visual to kind of remind you of making a cross. This creates a horizontal line. I'm going to apply the idea of making a cross to number 3b. 4x equals 12. Any questions on 3a? We're all good? All right. Give myself a little room here. Divide by 4 to both sides. Great. X equals to positive 3. Here, let's, instead of just thinking about it too much, go to the x-axis, put a dot on 3. 1, 2, 3, put a dot there. make a cross. Every point on this line has an x value of 3, meaning everything here. And when you do that, it fills in to be a vertical line. And there's your graph. Make a cross, makes a vertical line. All right. Any questions about that one? All right, let's take a look at the habits of mind question at the bottom. Given a linear equation in standard form, can you always find the x and y-intercepts? Explain. Well, we just came from an example with vertical and horizontal lines. When you graph one of those situations, you only get one type of an intercept, but not both. Because when you have a vertical line, there's only an x-intercept there, but no y-intercept for a vertical line. For a horizontal line, you only get the y-intercept, but no x-intercept. So they just wanted you to think about it a little bit. All right, let's go ahead to the next page. I remember this last year. We're actually going to skip example 4 and jump to the last page. Example, we're going to jump to the last page on page 42. Let's skip this page. Here we go. All right. So to summarize, we are doing standard form of a linear function ax plus by equals c. The technique is to connect the x and the y-intercepts by setting the other variable to 0. Take a look at number 5 here. Create a couple of spots here to solve for x plus 4y equals 8. We will find the x-intercept first. And take your equation and set y equal to 0 in the equation itself. X plus 4y equals 8. Y is 0, so that zeroes out. Oh, yay! X equals 8. I'm not going to graph it yet. I want to kind of eyeball how to graph these axes, how to create them. Let's do the y-intercept next. Set x equal to 0. Plug it in. X plus 4y equals 8. Plug in the 0 for x. And you just ignore that. And continue solving. Move the 4 to the other side by dividing by 4. Y equals 2. Yay. So it looks like I have 2 positive values. I'm going to go ahead and give myself a bunch of space in the first quadrant by adjusting my axes to represent that. On the x-axis, go to 8. Put a dot there. And on the y-axis, go to 2. And put a dot there. And all you have to do is connect it. No mention of slope, right? This is devoid of slope, this particular method. And there it is. Yay! Not too bad. We're going to do the exact same thing with number 6. Same process. Any questions about number 5? All right. Here we go. Number 6. Let's go and find the x-intercept. Set y equal to 0 again. Plug it in. Leave myself a little room there with a blank for the y spot, 0. It's cover up, right? It's gone, that middle term there, leaving with a 3x equals 24. Now I'm going to save a little room here. I'm going to divide by 3 to both sides. And that gives me x equals 8. Oh, that's weird. Same answer like the one above in number 5. Okay. Let's go and find the y-intercept. set x equal to 0. Let's do it. 3x minus 4y equals 24. Got a little cramp there. Sorry about that. Plug in 0 for x. That zeroes out. Bam. That leaves me, watch out for those negatives. Negative 4y equals 24. Divide by negative 4 to both sides. I'm sorry, divide by negative 4 to both sides. When you do that, positive 24 divided by negative 4 is negative 6. All right. Let's see, we have a positive 8 and a negative 6, which puts us squarely into the fourth quadrant. Let's give ourselves some more room here into the fourth quadrant and plot those two. Positive 8 again, right? 2, 4, 6, 8. And negative 6, this time way down there. Bam. Connect those two dots. Wow, that was not the best line ever. Try it again. All right, much better. Yay. All right. A couple more problems for the day. Any questions about number 6? Number 7, I only see you have a single variable, everybody, x. Let's isolate it. Divide by 5 to both sides. X equals 4. Every x value is 4. Every x value is 4. Make a cross. When you make a cross with that x-axis, it'll be a vertical line crossing through x equals 4 on the x-axis. Okay, that's easy. That's a vertical line. Yay. You guys ready for the last one? I am. Oh, you have another equation with only a single variable, which means it's either a vertical or horizontal line. Divide through by negative 3 to both sides. You'll get y equals negative 3. Oh, let's eyeball that. I don't need too much room. All right. Y-axis, x-axis. Go to y equals negative 3 on the y-axis this time. Put a dot there. How do I make a cross with that dot and the vertical axis? I have to draw a horizontal line that crosses through negative 3 on the y-axis. Okay? Well, I hope you guys learned something. I am finished with this lesson. Thank you very much. I'll talk to you next time. Have a good day.